Okay, let's look at the review packet. The first one is about geometric sequence and geometric mean. In the first one, it goes 2, 4, 6, 8, so it's not going up very fast. And for most of you, you pretty much can figure out that's a +2 and that's a +2. Now let's say you couldn't figure it out. You would do the second minus the first term. So 4 minus 2 equals 2, and you would see if that works in every case. So because we're adding, that's arithmetic. And our common difference is +2. Now the next one is 2, 4, 8, 16, 32. That starts going up much quicker. So in this case, this would be times by 2, times by 2. And so this is geometric because we're multiplying by a common ratio. Now the next one may be a little bit more difficult to figure out. And if you weren't sure, again, you could take your second term. And obviously there's division going on here, so you want to check and see. So the second term divided by the first term gives you 0.5 or 1/2. Or the other thing that means is we're dividing by 2. So each time you got to ask, are you dividing by 2? And if you check each of the terms, that's what's going on. So this is geometric. And there's two ways you could say this. You could say divide by 2 or multiply by 1/2, either of those. Now the next one, if you actually do this on your calculator, let's say I'm not sure. So I do 1/3 minus 1/2. Okay, so on my calculator, if I do 1 divide 3 minus 1 divide 2, math, frac, enter, enter, I get -1/6. And so that's saying I'm subtracting 1/6 each time. So let's try. 1/3 minus 1/6 gives us 1/6. So that didn't work. So it's not arithmetic. Maybe it's geometric. So I'm going to go 1/3 divided by 1/2. And so 1/3 divided by 1/2 gives us 1/6. So maybe if we multiply each time by 1/6, well, 1/3 times 1/6 is not 1/4, it's 1/18. So this is a pattern because they're adding 1 to the denominator each time, but it's neither geometric nor is it arithmetic. Okay, so that's what's going on with that one. Now remember, to find the geometric mean, let's see if I can do this correctly. It's extreme. Let me make this a little bit smaller. Okay, extreme over the mean equals mean, well, not over mean over extreme. Now the extremes are the two outside numbers. So my two extremes are these two numbers here. Okay? And then what I'm looking for is x. So that's going to be my mean. All right? So let's put those numbers in. 8 over x, because that's what we're looking for, and x over 72. We're going to cross multiply. X times x is x squared. And 8 times 72 is, 8 times 72, I divided, sorry. 8 times 72 is 576. Well, that's what x squared equals. Well, how do we get rid of a square? We square root both sides. So I'm going to square root, and that gives us x equals plus or minus. Now remember to find the square root button on your calculator. It's second and the x squared, and then you can put 576 and then hit enter, and you get 24. So the answer here is going to be 24 plus or minus. Okay, let's do the next one. I'm going to erase this here because I need the work. You can always pause it if I'm going too fast. All right, the extremes in this one are -2 over x equals x over -128. Again, x times x is x squared. -2 times -128 equals 256. Again, we square root both sides. And that'll give us plus or minus. So the second x squared 256 equals x equals plus or minus 16. Okay? Next one, same way. I'm going to do the same exact thing. The extremes are 324 over x equals x over 4. There are extremes. So we multiply. X squared equals 324 times 4, and that gives us 1296. Square root both sides. So x equals plus or minus 36. And then the last one is the same. It's just the same thing over and over again. And so this is what it's going to look like on the test. So we're going to do 1/8. This is a little harder over x equals x over 3. So we still get x squared. And 1/8 times 3 is 3/8. If you're not sure of that, you can do 1 divide 8 times 3. Hit your math button. Choose fraction to tell the calculator leave it as a fraction, and it'll give you 3/8. Now, in this instance, I said round to the nearest tenth. So you could use a decimal here, which we're going to do. So I'm going to take the second square root of 3/8. So I'm going to square root both sides. And that's going to give me plus or minus, x will equal plus or minus 0.6, because that's rounded to the nearest tenth. Okay, so that's 3.1. Okay, the next one is graphing. Let me make my pens a little thinner here so that they're easier to see while we're doing this. Okay. Sorry, I should have done this before. All right, let's do the first one. If we're talking about an exponential equation, the domain is all reals all the time. All real numbers. Now, all real numbers are referring to any number you can think of. Now, when you get to Algebra 2, you're going to learn about imaginary numbers, and that is beyond all reals. But for now, all real numbers. And if you want to do the fancy R, you can do that. The next thing is I'm going to pick up my calculator. In order to find the range, we need to know our boundary, or another word for that, the mathematical term is asymptote. Okay, so we're going to go to y equals on our calculator. We're going to go, let me write this down just in case. I'm going to erase it after I write it, so make sure you get it down or pause it. Y equals 3. Y equals all the way top left corner. The caret key. Now the caret key is in the right column right below the clear button. That's really an arrow telling it to go to superscript. It's telling you put what's coming up next in the exponent. Now I always like to use the x ton button, I call it. It's actually xt theta n because it's quicker. It's actually lowercase n, sorry. And it is in the middle, right by the alpha. It's in the second row, second column, third row, pretty much. So you hit that, and now if you need to come down, you need to use your right arrow key. That's not a caret key, that's a caret key. And then you put your plus and your 2, okay? So I'm going to do that real quick. 3 raised to the x power, come down out of the exponent, plus 2. Then I'm going to hit my graph button. This is going to give me a visual of where my boundary is. And if you look at this boundary, you can see the boundary is at positive 2. In other words, it's skimming along. Ooh, I don't want it that. Let me make it really thin here. It's skimming along the 2, but not crossing it. So let me see if I can do it. Oops, I didn't pick it. Okay, there it is. That's my boundary. You don't have to draw the boundary in, but I want you to see where it is. And that boundary is where y equals 2. Okay, now you can't just draw a random loop there. We're going to use the table. So hopefully you got this down. I'm going to erase this. Now to find your table, if you already have your graph in there, you already put your equation in, you can hit the second key and your graph, because the second function on graph, which is top right, is table. Now, some people have said to me, well, I can't find my negatives. You can use your arrow button to arrow up and down to get where you need to be. So negative 2 is 2.1. And negative 1 is 2.3. And I'm just rounding to the nearest tenth. And then 0 is 3. And then 5, 11, 29. So 29 is not going to fit on there, but we have a good idea what's going on. So negative 2, 2.1 is just above the orange line. And then 2.3 is a little bit higher than that. And then 0, 3, that's our y-intercept. That's important. 1, 5. 1, 2, 3, 4, 5. And then 2, 11, 6, 7, 8, 9, 10, 11. And then 29 doesn't fit. So we go up this way. I saw in some of your homework that's as far as you went. That's not correct. You need to show that you're skimming along this. Whoa, what just happened? Let's see if I can get back. There we go. I apparently hit that. You need to show that you're skimming along your boundary. What I do not want to see is this. Do not do this. This is not what an exponential looks like. It needs to be skimming on one side and going up fast on the other side. Okay, so this part is wrong. Now let's talk about our range. Our range has everything to do with our asymptote or our boundary. We need to know, where is y? Is it going above? Is our graph above the asymptote or the boundary, or below it? And in this case, it's above it. So y is always going to be greater than 2. That means no matter what number I pick to put into this equation, I will never get a number less than 2. Okay, let's move to this one. I'm going to do this one a little faster. Again, you should know the domain, all real numbers, or the big R. I'm going to go to my calculator. I'm going to go to y equals. I'm going to clear out what was in there. I'm going to do parenthesis, 1 divide 3, close parenthesis, caret key, the X ton button. I'm going to look at my graph to see what I'm skimming along. And it's skimming along the x-axis, so it's skimming along here. Well, what does y equal right there? Right here, y equals 0. So that's going to be our boundary, our asymptote. Then I'm going to go second graph to look at my table. And -2 is 9. -1 is 3. Then 1. Then 0.3, then 0.1, then 0.04, okay? So I'm going to start up high, -2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it goes to 3, and then it gets 0, 1, and then it just gets closer and closer to our asymptote without crossing. Again, come down, skim along it, and make sure you put arrows on either side. Let's get our range. We know our range is going to be y, and on the other side is 0. Well, is the graph greater than the asymptote or less than, or the boundary? It's bigger than. So it's all numbers greater than 0. Okay? Oh, there's only 2 of those. That's great. All right. These you're going to have to pick out which one we're going to use. Okay? I have them memorized. You should have them written on your cheat sheet. Hopefully I have them memorized correctly. Let's see. So the first one says, the population of Las Vegas, Nevada has been increasing. So we know it's increasing. So it's not a decay. It's either growth or compound interest. At an annual rate, well, here's my rate. So I'm going to put an R there. That's my rate of 7%. Now remember, we have to take that 7.0 and divide by 100 in order to make it a decimal. So that's going to be 0.07. Okay, so that's our rate. If the population was 404,288, well, that's our start. So that's our initial. Right in the year 1999, A says write an equation to represent the growth. Okay, well, that tells us we're talking growth. If I need to know between growth and compound interest, I have to see the word compounded or compound interest. If you don't see the word compound or compounded, it's a growth. If you see the word decrease, that's automatically decay. So just in case you forgot, here's the formula. It's y equals A. Increasing is 1 plus r to the t power. The first one is asking for an equation. That means we don't get an actual number. We're going to just fill in the letters that we know. We know the starting is A, so that's 404,288. Then we're going to add the rate, which we figured out was 0.07. And in this case, we don't know the t. It tells us just leave t as t. Now, in the next problem is when we're going to put in a number for t. So it's the same equation in part B. But this time it says 2010. We got to look back in the problem and see, where did this start? It started in 1999 and went to 2010. That's 11. So we need to raise this to the 11th power. So I get my calculator, not the y equals. We're not looking for a graph, so stay in your home screen. And I'm going to go 404,288, parenthesis, 1 plus 0.07, close parenthesis, caret key 11, and then I hit enter. And I got, now we're talking about people, so I'm going to round this to 850,966. Okay? The next one. Carl Gossel is a machinist. He bought some new machinery for $125,000. Well, if that's what he bought it for, that's probably our beginning. He wants to calculate the value over the next 10 years. Okay, that's going to be important for tax purposes. Okay, well, that tells us some, but not everything. I'm still not sure what I'm using here. So part A, if the machinery depreciates, there's my key word. That means this is a decay problem. So let me write down the decay equation. Y equals A, 1 minus R raised to the t power. 125,000 is our A. 10 years is going to be our time, probably. It doesn't say a rate until we get to part A, where it says 15% per year. So that needs to be divided by 100. So our rate is going to be 0.15. Write an equation to represent the value of the machinery since it was purchased. Okay, it doesn't want an answer right now. What it wants is Y equals A, which is 125,000, 1 minus 0.15, and you should put a T here. Then it says, now this is a key here, watch out, to the nearest 100. So we're going to round to the nearest 100, but it's telling us now to make T equal 10. So Y equals, ooh, we cannot use one that is way too thick. All right, let me erase that because it looks terrible. Y equals 125,000, 1 minus 0.15 to the 10th power. I go to my home screen. I type that in exactly with the parentheses. And I get $24,609. It said to round to the nearest 100th. So it's going to be Y equals $24,600. Now, it was depreciating, so I'm going to take a quick look back. It was originally worth $125,000. Now it's down to $24,000. That makes sense. It's depreciating a lot, and it's been 10 years. Okay? Number 11 says a $300 investment is in an interest rate compounded semi-annually. As soon as you see compounded, we know we're talking about compound interest, which is the hardest one to do. It's Y, well, it's not even Y equals, sorry. It's A equals P 1 plus R over N times T. So we know 300 was our original, so that's our P. Our interest rate is 6.75%, but we need to divide that by 100, so it's 0.0675 is our rate. That thinner too. Okay, and it says semi-annually, so you should have that in your notes. Semi-annually means n equals 2. Twice a year this happens. Okay, so let's fill in what we know. We don't know A. We know 300 is our original. It's 1 plus 0.0675 over 2, and then it's 2t because we don't know yet. Then we use that same equation and we go A equals 300. Now, this is one where you want to simplify. I'm going to put 1 plus 0.0675 divided by 2, and that's going to give me 1.03375. So I simplified inside. And then 2 times 20, I'm going to make that 40. So let me erase that because I'm running out of room. And I'm going to make that 40. So now I put in my calculator 300 parenthesis 1.03375 close parenthesis raised to the 40th power, and that's going to equal, as soon as I have something to write with, 1,131, and we're talking about money, so I'm going to round to the nearest cent, 73 cents. Does that make sense? Well, it was originally a $300 investment. I left it in for 20 years, so that's not unreasonable. Now, the next one on yours should have been fixed, but it says write an equation to represent the situation. Okay, so I'm going to write this equation, but first I need to figure out what we're talking about. It has a savings plan for employees. We're talking money. If the employee makes an initial contribution and pays this, there's my compounded quarterly. As soon as I compound it, I know I'm going to use this equation up here. So let's see what A is our P is our original. That's what we put in to start with. Here's our interest rate, and if we divide it by 100, it's 0.08. Compound it quarterly, so that n equals 4. It's not telling you a time because it just wants an equation. So it will be A equals 1,000, 1 plus 0.08 over 4 raised to the 4t power. That's your answer for this one because it's just asking for an equation. Okay, now 2 more. We have to do the, we need to do the extra credit. Brenda, so first we have to decide. All right, compounds monthly. There we go, compound interest. So it's going to be Y equals $150, 1 plus, well, let's see. Oh, no, that's wrong. Let's read it again. She's deposited the money in the bank, compounded. Let's write the compound interest equation to start with. Let's start there. Y equals P 1 plus R over N times T. Let's see what we know. She deposited the money in the account, compound it monthly. So we know N equals 12. See, I tried to rush it, and then that wasn't a good idea. So N equals 12. I get that from there. Here is our rate. Just because there's a decimal on it doesn't mean it's a decimal. It still has the percent on it. So we need to divide by 100 here. So our rate is going to be 0.00876. Yeah, okay. Now, what did she originally deposit? $100, okay. So that's our original, that's our principal. So I'm going to put that as my P. When will she have 150? 150 actually stands for our Y. The question is, when will Y be 150? So let's write this out. 150 equals 100, 1 plus R over N, 0.00876 over 12 to the 12t power. Okay, so we got to figure out how many years. Well, there's a way to do this, but it's way beyond what you've learned. So we're going to have to use a table of values. Okay, we're going to put in a time, and we're going to see how much money that is. Okay, we're going to figure out our Y. I'm going to start with 1 year just to see what it does. I'm going to simplify this a little bit. We're trying to get to 150. So, I'm going to do 1 plus 0.00876 divided by 12. And so just to make it easier when I go to do this, I don't know why I put that. So inside here is going to be 1. I just simplified inside here. 0.00073, and that's raised into the 12t power. We're trying to get it to 150. So I'm going to start with 1. So I'm going to make t 1. If t is 1, that's 100, parenthesis, 1.00073, close parenthesis, raised to the 12th power, because 12 times 1 is 12. Well, that gives me $100.88. Close, but not quite. It's a little bit far. So I am going to skip down, just for the sake of it, to 5. And I'm going to see what happens if I do 5 years. So I kind of know where I need to go. So I do 100, parenthesis, 1.00073, close parenthesis. Now 12 times 5 is 60. So I'm going to raise it to the 60th power. I'm getting a different answer than before. I got 104 point... Make sure I did this right. 0.0876 divided by 100. 0.012. Ooh, oh no. Okay, I'm good. Okay, I guess last time. So that's not far enough. Let's go down to 10. Gotta fix this. So let's try that. 100, because I'm trying to get to 150. 1.00073 raised to the, well, it's this time I'm going to do 10 times 12, so that's raised to the 120th power. Did I really make this problem this hard? I don't think I did.